We started talking about bus admittance matrix, and today also we will conclude the topic. Basically, I will be reviewing, and then some more practical problems we will look at forming the bus admittance matrix today. And as you recall, at the end of the lecture number 10, today is lecture 11. So at the end of the lecture number 10, I had given this challenge homework, and I have given two questions. And I also mentioned that question 1 is very easy, but question 2 is very difficult. Although they look. So if I quickly review the question, there is a voltage source and the voltage is V1 and delta 1. And there is a transmission line whose resistance is not given. That means it can be assumed 0. Only the reactance is J5 ohms. Then at the other end, there is a V2 delta 2, the voltage and angle at the receiving end, where the load of 10 kilowatt plus J5 kVAR is connected. So this is the simple system, just two buses, one voltage source and one load. Now the thing is, if V1 and delta 1 are given, it is difficult to find V2 delta 2, whereas if V2 delta 2 is given, it is easy to find V1 delta 1. So that is what I have given in the question. And already some answers, in fact, I have received only two answers. Question is easy, so that's why I imagine the answer is matching. Whereas coming to the second question, here the answer is 976 and here the answer is 808. So it is not matching. Similarly, the angle is minus 2.935 degrees, whereas here it is minus 8.85 degrees. So even the angle is not matching, magnitude is not matching. But what about the correct answer? So the correct answer, I have only received two answers so far, and let. So question 1. It will have some this thing. So we will solve it in lecture 12. Sorry. Okay, so now if somebody has a doubt how to solve the first question, it's very simple. Just V2 is given, so V2 by S will give you the current. That current into the impedance here will give you the voltage drop. That voltage drop you add to V2, you will get the V1. So the both answers we got so far are correct. So I'm not going to discuss that further anymore. But this question number 2 we will come back. Meanwhile, you can still try. So question number 2 listed above is still open for next 48 hours. We will solve it in the next lecture. So with that, shall we begin today's class? This bus admittance matrix, and I'm just going to continue this topic. So last class we had talked about this. So I hope you all got something from that. So let's continue our topic in today's class. So let me briefly review how you. So we'll just solve a simple question, and from that we will just briefly review how we've created a bus admittance matrix. For this, I am taking a small problem, something like this, 6.6 from Power System Analysis textbook by T.K. Nag Sarkar. I'm just giving you from where I got this problem, but then this is not, if you don't have this book, don't worry. So just look at the question. So the question is build Y bus. Okay, and the network is like this. It's a 3-bus network. So this is bus 1, this is bus 2, and this is just a minute. And bus 1 is connected to the ground using an impedance, and bus 2 is also connected to the ground using an impedance. So this is J0.5 and this is J0.08 and this is J0.03. This is J0.05 and finally this is J0.2. So I'm giving you these values. So based on this, the question is to build Y bus. And what is the procedure I have told you? In the last class, we had discussed the procedure. So I'm just solving it now. So step 1. So step 1 is admittance diagram. So how do you build the admittance diagram? You convert the impedance. How do you know that this is the impedance? First of all, it will be given in the question that the impedance value is this much. And even if it is not given in the question, if it is a positive value, that means it's a reactance, and a transmission line will have a prominently its value to be reactance. So like this. And here the resistance is not given. Sometimes the resistance will also be given. In that case, you need to calculate it more accurately. So like this. So what is J0.08? We have to take it 1 by this. Okay, so in the admittance diagram, you just draw the same diagram once again. But here you will show all the admittance values. So let's begin here. So J.2. So 1 by J.2 is minus J5. So because the reciprocal of this 1 divided by 0.2 will be minus J5. And what is the reciprocal of this one? Minus J0.05. So that will be J20. And this will be J33.33, I believe. And then this one will be 1 divided by 0. Let me just quickly check that on my calculator. $12.5 and finally 1 by J0.5 is J2. Of course, I forgot the minus sign everywhere. So I just put the minus sign. Why you get minus sign? Because 1 by J is minus J. So once the step 1 is completed, so let me put the bus numbers. So this is bus number 1, bus number 2 and bus number 3. So this one ground you can consider all the time as bus number 0. Because the voltage of the ground is always 0 volts. So let's now once we have the admittance diagram, step 2 is you form the Y bus. So Y bus size you already know because there are 3 buses, you have 9 elements. So I just make some place like this. So this is the columns, first column. This is the second column, this is the third column. This is the first column, second column and third column. So I always write like this so that it is easier for me to fill the values. So you can also make it as a practice. Otherwise, if your handwriting is already nice, so you can right away draw it. So now, any line connecting from 1 to 2, yes, there is a line. So the negative of that you take. So that is J12.5. Is there any line connecting from 1 to 3? Yes, there is a line connecting from 1 to 3, that is minus J20. So here it will become plus J20. Now these two elements will just simply be copied here. The element. Is there any line connecting 2 and 3? So 2 and 3, yes, there is a line connecting, that is minus J33. So it will become plus J33.3. So that J33.3 will come here also, like this. Now coming to the diagonal elements. So what you have to do, you have to add all these row elements. So 12.5 plus 20 will be 32.5. But then there is a J5 connecting from 1 to 0. That also I have to add here. So that I will, let me add that here. So here, if I write it individually, so it will be J 12.5 plus J 20 plus J 5. So I have to reverse all the signs. Then finally, overall, I should give a minus sign. So that is the thing. So let me write this directly. So at bus 2, if I add everything in the row 2, 12.5 plus 33.3. So 12.5, 33.3. And I have to add the 2 also. So 2. So this is 0.8 and this is 7 and then 47.8. So here it will become minus J 47.8, like this. So coming to the last, at 3 there is no resistance or impedance connecting to the ground. So I just add these two, 30 plus 33. So it will be minus J 63.3. So this is the completed Y bus for the network. So this is just a review of the last class. So what we have done, uh, first given the impedances, you draw the admittance diagram, and once you draw the admittance diagram, then you create the empty Y bus with correct number of rows and columns. Then first fill up the off diagonal elements. If the connection is there, then you reverse the sign and write it. If there is no connection, you put 0 and then you can do that. So finally, what will happen to this Y bus? So, you know what is the Ohm's law? So, and this will be n rows, one column. This will be n rows, n column. This will be n rows, one column. So these two are I and V are column matrices and Y is this one. So I hope you got this correct. So far, if you have any doubts, you can ask. Any doubts about formation of Y bus? I'll just wait 2 minutes. If anybody is having a doubt, you can ask your doubt. So let me just write it once again. Okay, so I just made a mistake because between 1 and 3 it is that. So again the question is explain how Y-bus matrix is formed. So we will be doing enough examples today. So every example I solve, you will be able to learn that. So let's do one more example. So this time I am doing another second example. This time I want to use simple circuits instead of all these things. I'll just want to solve a simple circuit. So question 2 for today. This is not from any textbook. This is my own question. Okay. Solve the following circuit and find all node voltages. So this is the question. So the question is like this. So Let me just, let me just make a connection here like this. So this is my network. So let's just enter the values. So let's say this is 2 ohms, this is 3 ohms, this is 5 ohms, this is 3 ohms, this is 6 ohms, or 4 ohms, this is 8 ohms, this is 4 ohms, and this is 20 volts, this is 30 volts, and this is not 30 volts, let's make it 40 volts, and not 40, I'll make it 60 volts, and let's say this is 20 volts. Okay, so somebody gave you this question and asked you to find all the node voltages. So let's mark the nodes. Okay, so let's call this V1, let's call this V2, let's call this V3, let's call this V4, V5, V6, and that's it. In fact, let me just see, we should identify ground voltage, so 0 volts. So this is V3, this is V4, this is V5. So the question is, find V1, V2, V3, V4, V5. So can anybody explain how will you find it? How do you find V1, V2, V3, V4 and V5? We are going to solve it in next 10 minutes, but then I am asking you to solve it. How do you find V1, V2, V3, V4, V5? So can you think about the method to solve this? Nodal equations, and then you have to solve the nodal equations and all these things. Okay, so that is one method. That's correct answer. So V equal to Zi. So let's use our whatever we learned in power system, let's apply to circuits. So what you learned in power system? You learned in power system how to form Y bus. So let's apply that and then see what happens. Okay, so I'm going to solve it. So let's see how much time it takes to solve this. So here now, so time is 11:23. So let's see what is the procedure. So first thing is convert all the resistances into admittances. Okay, so that's what I'll do now. So I'm just copying this circuit. I convert this into 1 by 3. So into admittance. So what is 1 by 3? It is 0.333. What is 1 by 3 here again? 0.333. 1 by 5 is 0.2, 1 by 4 is 0.25, and 1 by 2 is 0.5, and here 1 by 10 is 0.1, and 1 by 8 is 0.125, 1 by 4 is 0.25. So first, step 1, convert R into G or conductance, G equal to 1 by R. So any doubts up to here? So next step is step 2, replace voltage say replace with Norton's equivalent. So what is Norton's equivalent? So if you have a resistance and a voltage source V and R between the two nodes A, B, this is equivalent to a current source in parallel with a resistance, and this node is A, B. So this is same is R, and this one is nothing but V by R. So this I equal to V by R amperes. So you can replace the voltage source in series with a resistance between the 2 points A, B using a current source in parallel with a resistance between the 2 points A, B. You can do like that. So let's do that here. So what I can do is look at the circuit. 20 volts is the voltage source and 2 ohms is the resistance. So I can just replace it with a parallel current. I can just short circuit the voltage source. So I just short circuit this one and then replace with a current source. So this is short circuited. So this 20 volts is not there. And how? Similarly, this one I can short circuit this and replace with a, so the direction of 10 amperes is towards V1, same direction we need to maintain. Replace with a current source, and this one is 15 amperes. Similarly, this I can short circuit and replace with another current source. The direction should be this way and it is coming here. And this one is 20 by 4. It is 5 amperes. So I hope you got this correctly. So I hope there is no doubt in this. So let me just highlight this. So we short circuited all the 3 voltage sources, replaced with the current sources. Okay. Any doubts up to here? Step 3, write the I-bus matrix. So what is I-bus? So I-bus is nothing but externally injected currents. So we want I1, I2, I3, I4, I5. So I think there are 5 nodes in our network. So what is I1? So now if I go back, externally 10 amperes is injected into the node 1. So I1 is plus 10. Okay, so I1 is plus 10. Next, go to node 2. Externally, there is no current source, only the internal currents are there. So what are the internal currents? Current going through 3 ohm resistance, current going to 5 ohms, and current going to 3 ohms. So internal currents we don't worry, external currents we worry. So I2 is 0. Similarly, look at the I4 is also 0 because at node 4 external voltage source is not there. So I2 is 0, I4 is also 0. Now let's look at I3. Now go back here. At node 3, externally 15 amperes is entering into the node 3. So 15 amperes entering into node 3 from outside. So that's why I will write 15 amperes here, plus 15 amperes. What about I5? So you look at I5, 5 amperes is entering into 5 and 15 amperes is leaving into 5. So 5 is plus and 15 is minus. So 5 minus 15. 5 amperes entering into node 5 and 15 amperes leaving node 5. So that one I will write it here. So plus 5 minus 15. So that is equal to 10, 0, 15, 0 minus 10 amperes. So this is my I bus. So externally injected bus currents is this one. So any doubts up to here? I replace the voltage source with current and then any doubts up to here? Okay, so if you don't have any doubts, so let me just go back and then so I'll once again copy this to do the next step. So what is the step we are in? Step 4. Build Y bus. So how do we build Y bus for this? So there are 5 nodes. So I'll make a 5 by 5 matrix. So 1, 2, 3, 4, 5, and then 1, 2, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this is my Y bus. Okay. So you know the procedure. How to build Y bus? So look at this. This is node 1, node 2. Between 1 and 2, 0.333 is there. So minus 0.333. Let me use a different color. Okay, next between 1 and 0, there is 0.5. Okay, so I'll just put minus 0.5. So 1 and 0 means I'll put it in the diagonal element. Okay, next, this one we considered, this one we considered. Next, between 2 and 3, 0.33 is there. Okay, so first of all, I'll just copy this. Between 1 and 3, nothing is there. Between 1 and 4, nothing is there. Between 1 and 5, nothing is there. Now come to 2. Between 2 to 3, again I have 0.33. So second row, third column, minus 0.333. Between 2 to 4, there is 0.2. So minus 0.2. Between 2 to 5, nothing is there. So I just copy this. Now coming to, so we have utilized this one, we have utilized these two. Now coming to the fourth node is connected to the ground. So it is connected to the ground 0.1. So I'll just put minus 0.1 here. And then fourth node is connected to 2, already that is considered. Fourth node is connected to 5. So 0.125 minus 0.125. This is, sorry, I am putting it in on third. I'm sorry, let's look at third. So 3 is connected to 2, it is already done. 3 is connected to 5 with 0.25. So 3 is not connected to 4. So these two are 0. So this is minus 0.25 and this is minus 0.25. Next, 3 is not connected to ground, so nothing is there. Now coming to the 4, 4 to 5 is minus 0.125. Minus 0.125. And 4 is also connected to the ground with 0.1. Now I fill up the diagonal elements. So how to fill up the diagonal elements? Just simply add. So 0.333, 0.33. I'm looking at the second row. 0.333, 0.333, 0.2. I'll just add this 668. So this is plus 0.866. Similarly, add all the elements in the third row. So 333 and 25. If I add that, so plus 0.583. And look at the last one. So 0.25 and 0.125. So if I add this, so I'll get 0.375. Now coming to the first element, add everything. So 0.333 is there and then 0.5 is also there. So 0.833. So I just temporarily I have written this. So I'll just delete this and then I'll put plus 0.833. Similarly, in line 4, what I have? 0.2 I have, 0.1 I have, and 0.125 I have. So this is 5, 2, 4, 0.425. So this one I'll delete and then I'll put 0.425. So finally my Y bus is completed. So once my Y bus is completed, what is step 5? Okay. So we know that I bus equal to Y bus into V bus. So this is known and this is known. This is unknown. So how to get the unknown value? So Y bus is equal to, V bus is equal to Y bus inverse multiplied into I bus. So let's see, this is known, this is known. Let invert Y bus and multiply with I bus, then I'll get the V bus. Okay. So at this stage, I have to use my, because it is a 5 by 5 matrix, so I have to use a software to do that. So just, so far, do you have any doubts? Meanwhile, I'll open my interface. Do you have any doubts up to this? I'll be able to get that. So let me just set. This is my fourth row. 0 minus 0.2, 0, 0.425 minus 0.125. And what is my last row? 0, 0 minus 0.25 minus 0.125, 0.375. So this is my Y bus. So what is my I bus? So if I go up, I have just, if you refer to your notes, I bus is 10, 0, 15, 0, minus 10. So I have Y bus and I bus. So simply V bus is nothing but INV inverse of Y bus multiplied by I bus. That's all. So this is my simple code. So once I save this file, so let's say DC circuit. So I saved this file. Now I simply execute this file. I'll be able to solve the values of Y bus. So if I just run this, so here is what the solution. So on the screen, on the right side, you are finding the solution. So I'll just write like this, V bus equal to. So at the top, I have the Y bus matrix, and then I have the V bus matrix. Okay, so again, thanks to Jntuk Kakinada, some mistake I have done. So Y50 is 0.25, that is not included. Yeah, so this last one I forgot to include. So let's correct that. First, let me go back and correct that. So this kind of mistakes commonly people make during exams. So don't make like mistakes like me. Check carefully everything. So this 0.25 I forgot. So this is between 5 and 0. So here I have to add a plus 0.25. So if I add plus 0.25, it will be 5, 1, 2, 0.6225 you will be getting here. Okay, so I'll write it here. Y55 equal to, what is Y55 equal to? Anyway, I'll just delete this and write it here. So this is 0.625. Okay, so small correction. Uh, Thanks to JNTU Kakinada for correcting. So I'm writing down all these things because you should all cross check. Every time I make some mistake, you should be able to tell that. Okay, so let me go back to my code. So rest everything is same. So let me go back to my code and then I'll edit that there. So what I will do now? So I'll simply go to the matrix here. I'll say 625 and then I save this file and again execute the file. Then I get the current. Sorry. So this is the final V bus I'm getting. So let me write it here. MATLAB. So I'll write the MATLAB code here. So basically this is the code, this is the result. So what is the result I got? So basically I solved all the voltages. So V1 equal to 24.16 volts, V2 equal to 30.4 volts, V3 equal to 45.4 volts or 45.38 volts, like this. V4 equal to 15.87 volts, and finally V5 equal to 5.33 volts. So like this I am able to solve. So what is the time? It is now 11:49. So how much time did we take to solve this? I started at I started at 11:23, I think. So 11:23 to 11:49. So about 25 minutes or 26 minutes. So you can, within half an hour, I am able to solve a very large network. So like this. So of course, we can even make it faster. So now let me again pause for a minute and then ask you any doubt. So I just wanted to mark the voltages. So this is 24.16 volts and the voltage at V2 is 30.4 volts. Voltage at V3 is 45.38 volts. Voltage at V4 is 15.87 volts. Voltage at V5 is 5.32 volts. Okay. So like this. So you can always cross check. See what is the current flowing in this. Since you know V2 and V4, the voltage difference you know, and divide by 5 ohms, you will get the current in this. You can get the current in this branch, you can get the current in this branch. Like that, each branch you can know the currents now, once you have the voltages. So anyway, any doubts? Okay, the question you are asking is invert of Y bus is nothing but Z bus. So the college, Sri Vishnu Engineering College for Women is inverse of Y bus nothing but Z bus. So the answer is yes. So just now we inverted Y bus, so that is nothing but Z bus. So you want to see Z bus, so I can also show you Z bus. So what you do is, I go back to Octave, inverse of Y bus. So I'll just put the disp. That means it will display the Y inverse of Y bus. So here what you notice, this is nothing but Z bus. Okay. So let me expand this a little bit. So now once again I'll run it. Okay. So what you are getting, this one is nothing but the Z bus 1.63945. So Z bus is little difficult to calculate directly. You can calculate Y bus and inverse it. We will also see how to find Z bus separately. Okay, we still have half an hour left. So before we complete this half an hour, I want to solve slightly bigger problem, but I want to also teach you how to write a program. Okay. So some of you might be knowing this MATLAB, but then using that, how to solve it programmatically, I want to show you. Okay. So let me give you one more question, last half an hour. So typically, you from the textbook, you just learn the theory. But in this course, I want to teach you both theory and practical also. So that's why I want to show you easy method to build this Y bus using some MATLAB coding. So we have about 35 minutes. So that is sufficient to learn this thing. So let's take a problem. So the problem is something like this. Build Y bus for this network, and the network is like this. It's a generator, then I have bus 3, bus 4, and this is bus 2, and this is bus, so J4, this is bus 1, this is J.2, and this is J.2, and this is J1, and this is J0.8, and this is J0.08. Okay, so this is the question. Create a matrix with line data. That means whatever is the data of the transmission lines. So basically it will have three columns. So first column will be denoted as, okay, so line data. I'll write column 1 will be from bus, column 2 will be to bus, and column 3 will be impedance. In per unit. So like this. So let me, maybe I'll use this space here. From bus, to bus, and impedance. This is a basically tabular form of data. Okay. So look at the lines now. So from bus is 1, to bus is 2, and J.4 is the impedance. So this one I'll do that. So 1, 2, J 0.4. So this line is completed. Next, look at this line. 1, 3 and J 0.2. So 1, 3, J 0.2. So this line is completed. Then this line. So 2, 3, J 0.2. So 2, 3, J 0.2. This line is completed. Then this line is between 3 and 4. So 3, 4, J 0.08. Like this. This part is also completed. I have two more branches. So this branch is between 1 and the ground. So actually there is no ground. There is a generator here. But if I replace this with a Norton's equivalent, then the Norton's equivalent, this will become a current source and this will become a impedance. So therefore I can put as 1 and 0. So 1, 0, and it will become J1. And this one will be 2, 0, 2, 0, and then it will become J.8. That's it. So this is my data. So this is line data. So once I have this line data, I can read this line data and create. Let's do that. Any doubt up to here? So I got two questions. So let's discuss. So I got one question from Pragati Engineering College. I say PEC. Question is how to calculate Y bus without software. So the answer to this question is we already did some examples with hand calculations. So today first problem we solved and today some problems we solved. The first problem that we solved today is in the hand calculation. So I'll say refer to problem 1 solved in lecture 11. That is today's. So this is hand calculate. How to calculate Y bus without software? We already did some examples with hand calculation. Refer to problem 1 solved in today. Now continuing to this, if size of network denoted by n, so n less than 4 or something like that, or less than or equal to 4, you can do hand calculation. So if n greater than or equal to 4, so example n equal to 200 buses. When you are solving a large network having 200 buses, then definitely computer is needed. So that is the objective. So why we want to, however, hand calculation very important because you should know the understanding, you should get the concept. But once you learn the concept, if you stop there, then it is not sufficient. Oh, okay. So just a clarification. So again, Pragati Engineering College. So question, how to invert Y bus without software? So this is the question. How to invert Y bus without software? Okay, so for hand calculation, you can still do it, but use of computers is recommended. So use of computer is must actually. So did you, if size is 4 by 4 or 5 by 5 or 6 by 6, any math textbook, if you find any formula, please email me. As far as my knowledge, there is no direct simple formula for inverting a 4 by 4 matrix. I hope that solves your doubt. Yeah, so adjoint y by determinant of y, all these things. Whatever, something like that, you can do it. So I hope this clarifies your doubt. So one more doubt I got, that is, so this one. Let me paste the doubt here. Okay. So this is from JNTU Kakinada. So the answer is how Y bus inverse is equal to Z bus. Please explain. Okay. So we will see in later lectures. That is after lecture 18 or so. So at least we require some 7 or 8 lectures. After that, we will come to this point, how Y bus inverse is equal to. Please continue seeing this course. So later on in this course, we will see how Y bus inverse is equal to Z bus. And in other words, see, simple answer also I'll give you instead of postponing this. I'll say, so we denote inverse of Y bus as Z bus. So it's just a matter of denoting. See, you get a Y bus, you invert it, some matrix you will get it, and that matrix we are calling it as Z bus. So it's just a matter of definition. It's matter of definition. So I hope you got this doubt is also clarified. Okay, so any other doubts? Data. So let's now I'll go back to my. I hope somebody might have noted down this table here. From what get this? Given the circuit diagram, how to create this table? So line number 1 to 2 impedance is this one, line number 1 to 3 impedance is this one, and so on. So this one I'll now enter into my MATLAB program. Now notice the program that I'm going to write on the left side of the screen. So this is a program to build Y bus. So line data. So I'll just call it L data. So just a so what is my line data? So you have 1, 2, 0.4 I, 1, 3, 0.2 I, 2, 3, 0.2 I, 3, 4, 0.08 I, 1, 0, 1 I, or 1.0 I, whatever, and then 2, 0, 0.8 I. So also let me just give this symbol, that is ending of the line. So this way I have defined the line data. Okay. So now I will define n equal to 4. So this is number of buses, system size or max number of buses. So this 2 is the input data. Okay, so here I'll say line data. So I'll say, I think I already explained it, so let's not worry about it. So here, so the coding starts here. So the above part is nothing but the system data and the below part is the actual coding. So what I'll do is I'll just write y bus equal to zeros n comma n. That's all. So if I now execute my program, so I have given the input data and then I am executing the program. So this is not a completed program. So I am just running this program. So if you look at this, so here on the right, you have Y bus all zeros. Okay. So now I want to calculate the off diagonal elements. So how I'll do it? So simply I'll take this. I'll run a for loop for this line data and then 1 comma 2 I'll add 1 by j 0.4. Similarly 1 comma 3 1 by j 0.2. 2 comma 3 I will add this value. So like this each element I will just simply add it to the Y bus. So what I'll do here, you see, for x equal to 1 to length of line data. So this symbol colon and 1 will take the first column of the line data. I am finding the length of that line data. So because I want to know how many lines are there. Okay. So here I'll simply write, or maybe if the second element is 0, then replace it. So this is if there is a 0 in the second line, then that 0 I am replacing with whatever is there in the first line. So effectively it will set y11 y1 like that. So this is the if condition. So that's all. So if I run this code, all the off diagonal elements of the y bus will be formed. So let me just run this code now. I'm trying to see the answer that is coming on the right. So now on your screen, you will find Y bus here on the right side. So first column is this one, second column is, this all is the second column, and this all is the third column, and this all is the fourth column. So, but then if you look at the diagonal elements, so second column, like this one, diagonal element still not set. So how to set the diagonal element? So off diagonal element already we have done. Diagonal element simply add the row and then replace with a minus sign. So that is what you have to do it. So that's what I will do it now. So again, for x equal to 1 to n, because there are n buses, y bus of x row x column is equal to minus sum y bus of X row all columns. That's all. I'm just taking row wise addition and then I'm adding it to Y like this. So So that's it. So I got the Y bus. So since it is difficult to read, what I'll do is I'll just print the imaginary component of Y bus. So if I just write imag Y bus, so then I get the imaginary component of Y bus because the real component is anyway zeros. So first let me explain it what I want to do it and then I'll write the code. So this is my line data. And then say y12 equal to 1 by j 0.4. Similarly, I will also say and y21 equal to 1 by j 0.4. Then I take the second line. So I have this. So y13 okay, or first row third column is equal to y31 is equal to 1 by j 0.2. So this is my logic. So I'll take the third line. So y2 comma 3 equal to y3 comma 2 equal to 1 by j 0.2 and so on. Like this I'll run this code. Here I get a problem because there is a 0, there is a problem. So how to address this screen, you will find the answer like this. So this is the Y bus that is created. So this is the code. So I'll share this code with you. Let me go back to my data and then I'll add the Y bus. So Y bus obtained from coding. So this is very fast and very easy. So I got this. So this is my Y bus. So since this is only imaginary component I am having, so Y bus is nothing but J into this one. Or I can write it minus 8.5J, 2.550, 2.550 minus 8 point, so these are all J. 8.75J, 5J0, 5J0 minus J 22.5, 12.5J, 12.5J and then minus J 12.5. So basically this is the answer that I got from Y bus. So just simply by entering the data, I am able to get the Y bus. Any doubts up to here? So I will share the code also. So any doubts up to here? So I'm just writing here the code and then the result. So this is my code. So this is y bus equal to. So now let's, if we still have maybe 5 more minutes, so let's quickly solve one more problem also before we end. So, but then meanwhile, I'm waiting. Is there any doubts? So this is again problem number 6.12. Okay, from power system analysis by Nag Sarkar. So the question is build Y bus. And the network is like this. So it's a 6 bus system. So bus number 1, 2, 3, 4, 5, 6. And then I have lines like this. And these two are also connected and these two is also connected. And then there is a generator here. So the data. So, so from bus, to bus, and then impedance, reactance. So I have 1 to ground, and then I have 1 2, 1 6, 2 3, 2 5, then I have 3 4, then I have 4 5, then I have 4 6, and then finally 5 6. So this is a big network. And then the reactance values. This is J.2, J.02, J.04, J0.02, J0.03, J0.05, J0.025, J0.05, J0.02. So this is the data that is given to me. So from this data, what is the Y bus? So again, the code that we have written very easily, we can use that code to do this. So since almost we are end of the class, so let me just take 2 minutes and then I'll wind up. So what I should do? The code is already ready. So I just have to change the data and then I'll get the solution to the new problem. So and then here I'll just change the data. So what is the data I have to change? So 10.2i, 12.02i. I'm just entering the data. So you don't have to write in anything right now. You can just look at the screen. So because since I'll be sharing this file with you, you can always run it later and see. So between 3, 4, 0.05 I. Between 4, 5, I have 0.025 I. Between 4, 6, I have 0.05 I. And then the last line between 5 and 6, I have 0.02 I. So the line data is given and the system size is now 6. That's all. I just have to run this and then I'll be getting the Y bus for this. So let's check how it comes. The rest of the code, no change. So I just run this code. So finally I got the answer. So let me reduce this so that I can display it properly. Okay, so this is my final answer that I am getting. So I hope you're again able to. So this is Y bus equal to. So minus J, or I think just J, into this matrix. So of course these are columns 1 to 5 and this is column 6. Okay. So I hope you are able to solve this. So this is the conclusion of the Y bus problem. So here we conclude. Y bus topic. But then in load flow topic, it is very much used. So next topic, load flow. So this is again the basic of your power system analysis. So also remember you have, I think you have only 46 hours now for the challenge problem. So I think with this, if you don't have any doubts, I will let